In this short video, we want to look at how many different ways we can arrange n objects in different groups of size r. Earlier, we were looking at the idea of a sandwich shop, where there was a certain amount of breads and a certain amount of proteins and a certain number of cheeses. And we were looking at the number of different sandwiches we could make. Well, we want to extend this idea to a really important topic called combinations and permutations. And this is a really important understanding for us to get as we get into the topic of probability and measuring possible outcomes. So let's look at a very simple example. Imagine if we just had two different shapes. And I want to, given these two shapes, choose two shapes. Well, this seems like a pretty straightforward question, or task. But let's think about the two different ways that we could answer this. As far as combinations go, and the point of this is to try to illustrate the difference between a combination and a permutation. In combinations, order does not matter. So I've got these two shapes, whether I've got the white and the red, or the red and the white, or the white on top of the red, or the red on top of the white. It doesn't matter how we're ordering them. And just for simplicity's sake, let's just talk about left and right. So it doesn't matter if the red is to the left of the white or to the right of the white. The fact is we have a white circle and a red, well, it's more of an ellipse, but a white and a red shape. So in combination, it doesn't matter what order you're in. However, in permutation, order does matter. So in this case, one permutation of these two shapes would be having white first and then the red. Another permutation would be the red first and then the white. So whereas combinations, I only had one different combination, for permutations I have two permutations. Okay, so given that, I want you to think. In a second, I'm going to ask you to pause the video, and I want you to answer this question. Write down an example of when order matters versus when order does not matter. So in other words, I'm asking you to try to think in your mind an example of when you have a bunch of objects, and if you choose the objects, when does the order not matter and when does the order matter? Think of an example of when of both, of when the order matters, and then think of an example when the order does not matter. So pause this video and take a second to write that down. Okay, let's extend this idea of combination and permutation even further. So now instead of having only two objects, we have three objects. And what we want to do is we want to take these three objects and we're going to choose three objects. So in terms of combinations, where order does not matter, how many different ways can I take these three objects and choose three objects? Well, remember, whether it's red, white, blue, or white, red, blue, or white, blue, red, the order in which we're arranging these, it doesn't matter. It's just that I have three of them. So, given these three objects and choosing three, the number of combinations that I can do is just one. But what about permutations? So let's get us started. So one potentially easy way for us to think about this is, instead of just moving all of these objects around, which we can, it might be simpler for us to say, let's call this red, white, and blue. And just for the first, as we get introduced to this, let's think about ordering this as, or counting the permutations in terms of, well, we have red, white, blue, and then we have red, blue, white. So what I'm doing is I'm just fixing red at my starting point, and then let's put white as the starting point. So then I have white, red, blue, and white, blue, red. So just to illustrate, the last one that I just drew would have been doing this. So, well, you get the point. It would have been putting the white one first, then the blue, then the red. And then the last step is putting the blue first. So, blue, red, white, and then blue, white, red. So, here are all the possible organizations of, or all the ways in which I can organize these three objects where the order does matter. And so how many permutations? There are 6. Okay, so what I would like you to do, just to extend this a little bit farther, is so how many permutations if there are 4 objects choosing 4, and what if instead of 4 objects, if there are 5 objects choosing 5, and what if instead of 5 objects, let's make this a little bit harder, n objects choosing n. Okay, so what I'd like you to do is just pause the video now and take a second to write this down. You may have at some point learned a very shortcut way. If you have, I want you to develop that and be able to prove that to me. And make sure you're writing this down, because tomorrow, the next time in class, you're going to bring this in and we're going to be talking about this. So pause the video now and answer these 3 questions. There's an important operation called the factorial operation. Some of you may have seen this before. And this will come up as a very useful technique as we're looking at combinations and permutations. So let's just suppose that we had some numbers, and this may look very familiar to you from what you've just done, like 4 times 3 times 2 times 1, or maybe you have 5 times 4 times 3 times 2 times 1. In other words, you've got a bunch of integers that are being multiplied together in successive factors descending. Well, we can write this using the factorial operator, which is to say, you look at what is the the highest factor here, in this case it's, if we look at the first case, it's 4, and it's going all the way down to 1 in multiplication. So this can be written as 4 factorial. And our second example down here, 5 was the highest factor, so that can be written as 5 factorial. So just as a little challenge problem for you to think about, what I'd like you to do is evaluate this division, 6 factorial over 4 factorial. And so what I want you to do is pause the video, write the problem down, get a solution, and once you're done, unpause it. Okay, so these are really common problems. 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial. But I could rewrite the top as 6 times 5 times 4 factorial over 4 factorial. And then we know, well, 4 factorial over 4 factorial, it's the same thing, so we could just cross that off. And what we're left with is 6 times 5, which is 30. So we'll be doing a lot of operations with factorials as we dive deeper into combinations and permutations. So let's keep this tool, this operator, at the ready and start seeing how it's going to be used. All right, so let's finish this video with a slightly harder problem where we have 4 objects and we're choosing 3. So as far as combinations go, now we're going to have, in the last bunch of examples, the number of combinations were always just 1. Given n objects, choosing n, you just get 1 back. But now we have 4 objects choosing 3. Well, the combinations of this, imagine you could have let's move this. So that could be a combination. Those 3 could be a combination. And we could create a bunch more combinations of these 4 objects. Going through the process of just creating a bunch of tables, and we're going to want to move away from this, but for now, you could have red, white. I guess that's more purple than blue. So red, white, and purple. You could have red, white, and yellow. So now let's not have red as the first one. We could have white, purple, yellow. Oh, and the one that I forgot is red, purple, yellow. And are there any more? I don't think so. So there are 4 different combinations. What about permutations? How many can you make? So at this point, let's stop the video here. I'm gonna, in a second, want you to pause it. But I want you, what I want you to do is answer this question: how many different permutations are there if there are 4 objects and you're choosing 3? Get a number. Show a couple different ways, if possible, of how you can arrive at that number. And in the next class, what we're going to do is spend more time thinking about how to formalize this process. In other words, what we want to get to where we want to get to quickly is, instead of thinking about 4 objects, we want to think about having n objects and choosing r possible either combinations and permutations, and be able to formalize a way of doing this a little bit quicker. But for now, let's wrestle with these ideas. Okay, so pause the video and figure out how many permutations of 4 objects choosing 3 you can make. Thank you for taking this seriously. See you soon.